Good evening. Welcome to my weekly Node-RED live stream. An hour or so of code development on something in and around the Node-RED project. So welcome if first time joining. I see in the chat we've got Softy2K, Jim Bob Squelchy, Noxy Boy. Great to see you guys. Welcome back. Hope for another fun week of streaming. Noxy says, oh, it still says Team IBM on Twitch, does it? Well, I really should fix that. I thought I had tracked down all of the various bios on various websites and social sites to fix. So I will go fix that after the stream tonight. So thanks for finding that. So what are we up to? Well, what's going on? Well, in the big scheme of things, we've got Node-RED 2.0 looking to get that ready to release later this week. I think the current plan is to get it ready to release this week. You know, all the non-code things we have to do, blog posts, videos, that type of stuff. Because we've also got to do videos for the Lint Tool and the debugger. So there's a bit more to do this release than past. And then we'll actually do the release launch on Monday next week, Monday or Tuesday next week. That's the current tentative plan. Obviously pending what surprises may come up through the week. Who knows? So, yeah. So that means here and now on tonight's live stream, I'm not going to be doing a big bit of sorry, someone's just pinged me. What are they saying? Anyway, sorry, got distracted. How rude of me. Yeah, so what we're going to do tonight is carry on what we were doing last week, which was adding some unit tests to the flow-parser utility. So the flow-parser is a library we've created used by the Lint Tool. You can give it flow.json and it builds an object model of it that to try and give a standard programmatic way of working with flow.json. Like I said, it's what the Lint Tool uses for all of the rules you write for the Lint Tool. It uses the APIs the flow-parser provides, and we don't have any tests. So I'm literally picking up from last week, add some more tests to get the coverage back up to where it should be. And then yeah, well, we'll see how we go for time. There's a couple of thoughts I've had about the flow parser for future features, longer term things, unlike short term things, but it might be fun just to start poking around, noodling around to see if they're interesting to work on. All right, so let's get started. If you're watching this on YouTube, I guess a lot of the context of what we're going to be working on is in last week's video from, what was it, the 5th of July. So I won't go into as much details about the flow parser as I did last week. So I'm going to sort of jump straight into it to try and get some good progress on it tonight. So let's switch things up. So here we are. We're in the flow parser code base. What we created last week were all of these tests to deal with some of the functions that the node object exposes. So the node represents a node in a flow, and specifically a node in a flow. We have a separate object for config nodes. So this is literally a node in the workspace. So it's got nodes connected before it, nodes connected after it. And this provides some utility functions that we wrote unit tests for last week. So get sibling nodes, get previous nodes, and get next nodes. So those are utilities for getting the nodes immediately connected to the node you call those functions on. But we've got some other functions, get downstream nodes, get upstream nodes, and get connected nodes that currently have no tests. And if we flip over to the code coverage, so this is freshly generated code coverage for this code, and you can see NR node, the coverage is the worst of them all, down at 62%, depending which measure. But yeah, it's yellow, the others are green. The goal in the next 40 minutes or so is to get that green, so it just feels better. And then we can look at some of the others. Can we get everything over 90% will feel like a better place to be than where we are at the moment. And if we dive into NR node, so anything highlighted in red is a line of code that the current test suite does not touch. Yeah, there's a few edge cases, scenarios, which we should come to at some point. But you can see get downstream nodes, it's big, get downstream nodes, get upstream nodes, and get connected nodes is a whole lot of red because they never get called currently. So what's the difference between, say, well, we've got two sets of terminology here. We've got previous and next nodes. So those refer to, like I described just now, the immediately connected. There is a single wire from the node you call the function on to the previous or next nodes. So that's what those mean. Downstream and upstream mean everything that can be reached. If it were a message to leave the output of a node, every single node that message could reach through whatever path is considered downstream, and upstream is going the other way. Everything you can reach going back up. So we want to write some tests. Now, the way we did this, the way we created our test cases last week was, let me remind myself. So here we have the test file. We created some test flows. Hey Nathaniel, good to see you. Yeah, we created some test flows. Test NR node. We create some test flows, and then in our test case we're loading them in, passing them through the parser, and then calling the various functions and validating what gets returned is what we expect. So yeah, the relatively simple task now is just to create some test cases that exercise the logic properly of the functions we have. So to create the test case, we need go fire up node red, which I already have here. So these actually are the test cases we created last week, and we're going to create some more. So in fact, why don't I just thinking through, I don't think this will break things. If I were to group them and label the group get previous next connected. So those are the flows for those testing those functions. And then we're going to just create some more complicated flows. And by more complicated, basically we want more than one hop between the nodes to test things. In fact, for convenience, I'm going to create, why did I do that? I'm going to create 5 nodes. Now because we don't really care what I was going to shrink their labels, but actually seeing their labels is handy because we are going to give them all names in a minute, so we're able to reference them properly in the tests. Just quickly wire these all up. So yeah, dead simple case where it's just a single branch, a single track all the way through. So this is going to be flow 4 node 1, flow 4 node 2. You see, this is where it's making the nodes all a bit wider, so my careful positioning is failing already. Move him back, move. Okay. So I think that's good to begin with, just to do some basic validation. So I export current flow, grab the JSON, go to my test JSON, paste that in. So I've still got all the old test cases, now I've got the new. And in here we want to start a new block of tests. Describe, that's a good question. What are we going to test first? Let's do downstream first. Just double checking. Right, I'm going to just copy and paste one of our existing tests for the sake of convenience. So get downstream nodes. What we're going to begin is, if we could get downstream nodes on flow 4 node 1, it should return 2, 3, 4, and 5. Yeah, I don't think that's controversial. Get downstream nodes, and then so validate node list was the helper function we created last time. So rather than because order doesn't matter, the order that the nodes returned actually is not significant. It by chance will likely be the order they're wired in, but as soon as we start getting branches and loops, the order is going to be slightly more well, it's deterministic in the fact that the algorithm will return them in the same order every time, but we don't want the test case to have that. The API does not make any guarantees as to the order, so our test cases should not make any guarantees. So yeah, these utility functions we created last week just helped us say we don't care what order these things appear in the result, as long as those are the only nodes that appear. Right. Okay, so that's the new test. Let's see if that runs. So we're in flow-parser and we do npm run test. Yep, 22 passing. Awesome. Get downstream nodes. What I'm actually going to do is just run Mocha directly. We don't need the code coverage table printing out every time. Yeah. Again, I'm not sure what to call this test yet. I mean, this is no branches, because that's what it is. So okay, so now let's rename these. What I'm trying to do is think of, we will adapt these flows as we go slightly, but I'm not going to create a single flow for each test case. I want, like I seem to remember this flow up here, yeah, these guys we used in a few different test cases. We're going to have the same deal. So flow 4, the one we've just created, we've used for get downstream nodes. We'll use it for get upstream nodes going in the opposite direction in a minute. So that's goodness. Now, technically, we've done check downstream nodes on this first inject node, and we've validated it's returned all of those. That's good. We ought to also test, if we test it on flow for node 2, again, we then want to make sure it only returns these subsequent, the downstream nodes. We don't want it to accidentally start returning the upstream nodes as well, because we wouldn't know with the test case we have at the moment. So rather than test it from node 1, we're actually going to test it from node 2, because that gives us, there's then something there for it to not return and for us to test that it hasn't returned. Whilst we go, because we want a lot of this to be symmetrical, so I'm going to add get upstream nodes at the same time and make sure we actually call it. Let's see. And then if we call it for the penultimate node, flow for node 4, then we would expect to get nodes 1, 2, and 3. Make sense? Oh, that's OCD says put them in the right order. Right. Come on, where are you, terminal? There you are. So let's run that. Yep, so that's all they're passing, and I expect them to pass because I know this code works, but we're not here. We're writing these tests to make sure if we change stuff in the future that all the quote-unquote simple functionality still works. Right. Let's do branches on single output. Is that interesting? So what I'm thinking here is what we'll create is if we move this node down here, okay, so we were up to node 5 I think, so node 6, node 7, node 8, node 9. Okie doke. Right. Export it. Current flow. What's going on? This is just, yeah. Okay, so branches on single output. We're still going to grab it from, call it on flow 5 node 2. And now when we call downstream nodes, see, it's an interesting question now. Does downstream so this could be an interesting I might be about to trip over some inconsistencies in what we call downstream. So in the editor, if I shift click on the right hand side of the node, or if I shift click in the middle of the node, it selects all the nodes that it's connected to. Okay. Now in 1.3. something, certainly in the current release, if you shift click over towards one side, if I do the left hand side, then it's selected this node and the upstream nodes. And here if I click on the right hand side, it selects the downstream nodes. Now notice downstream here includes node 6 and node 7 because they are technically downstream. They are, you reach them by going through an output of node 2. Now earlier I described downstream as being everywhere a message could reach, and that is where this definition doesn't work actually, because a message sent out of node 2 obviously cannot go back up to node 7 or node 6. But certainly in the editor, we call that downstream. Now this is going to be really interesting because I can't remember what I've implemented here for the flow parser. Excuse me. So, what do we reckon? Are we going to take bets? Have I managed to be consistent or not? Oh, Jim Bob, the chat's not showing up on the live stream. Let me have a look. You know what? It's not. Okay, what's going on there then? Is that connected? No, it's not connected. It's not displaying. Oh dear. Right, let's try this. Right, that might be reconnected. So if someone wants to say something in the chat, and I'll keep an eye on it to see if it shows up in the on screen on the stream, because I've got my own chat window in front of me here, and then I've got OBS. Oh, you're all saying hi now. Yeah, see, it's not showing up in the live stream. Oh, that's a pain. But Uncle J84, Tom Go Crazy, and Stephen, great to have you all here. You know what? Let's see. Do I dare do a quick bit of OBS work? This is going to go funky for a moment, guys. So let's let me remind myself how to do this sensibly. Right, we're going to do a display capture. Oh, look at that. That's, I don't know if you can see that. Is that showing? Yeah. See, it's trippy effect, isn't it? Right, if I change that to display 1, you can now see my whole screen, and I don't want you to see my whole screen. I'm going to show you to window, and I'm going to show you my Twitch Chrome window. Is that working? No. Okay, we're going to do manual, and we are going oh boy, hold on, let's see, cancel that. Oh, what's going on? Right. Okay, well that's worked, sort of. Now if I make it a bit smaller, I'll stick it over here. Is that working? No, it's gone a bit glitchy at the bottom. That's right, Jim Bob. It's good to know, because it's I like having the chat, because obviously on the YouTube replay, I like knowing that I'm actually talking to people. If I move this down, no, too far, move it up. There we are. Now the funny thing is, over here I've got to remember now, which wouldn't normally be the case, is if I drag a window over here, you're going to see it, but that's all right. Cool. Let's get back on. But thanks for everyone who said hi and confirmed the chat was working. Good to see you all. Where were we? We are, yes, our slightly curious definition of what downstream means. So I was wrong to describe it as everywhere that the message can reach, because it's more subtle than that, or it's broader than that. It's every node that you could trace a path from in either up or down once you go through an output of the node. Okay, now, yes, I did get distracted. So I'm just going to recopy that to the clipboard because I can't remember if I copied this over or not. Definitely have now. So what we're going to do here, branches on single output. We're still going to test from flow 5 node 2. Well, I say still, it is now flow 5 node 2. And I'm just going to make this into a list just to make editing it en masse a bit easier. So what we're claiming to be downstream from flow 5 node 2 is nodes 3, 4, 5, 6, 7, 8 and 9. So I've got 3, 4, 5, that'll be 6, 7, 8 and 9, I think. 3, 4, 5, 6, 7, 8, 9. What do we reckon? Is this going to pass or fail? Pass or fail? Fail. Expected 5 to equal 7. So that means the implementation is wrong. Or, yeah, the implementation is wrong. The flow parser's implementation is saying everything that is right. I just want to make, before I assert that, I'm going to add another backward tick here. Yeah. And this is going to be flow 5 node, ooh, type properly, Nick, node 10. So here we've got another whatever you want to call it, link back up. So I'm interested to see if the code as written is handling that or not. So we ran it before and the function call returned 5 and we thought there should be 7. I'm now saying, well, I think that should be 10 because I think that node should be found as well. I'm interested to see whether... So we've increased it now. Our test is saying there should be 8 nodes. So from here, 1, 2, 3, 4, 5, 6, 7, 8. Whereas the actual implementation was only returning 5. And I can tell you now it was returning these 5 here. So I'm intrigued to see whether it returns that upstream one as well. Okay, no, 5 and 8. So it has stuck to just returning things that a message can get to, is the way to think of it. It never backtracks, which is reasonable. I mean, it is a reasonable interpretation. The challenge is it's a different interpretation as what we have in the core of Node-RED. Let me just go and try and remember where we have that in the editor. Don't open comms, thank you. It's in View Tools, I think. Here we are. Select connected nodes, then select downstream and select upstream. So select it down. So if you say down, it calls red.nodes.get all downstream nodes. That's what we want to go look at. Yeah. which in turn calls get all flow nodes for the node and the direction set to down. Yeah, and excuse me, so I just, yeah. So the algorithm the editor uses is, you start on what we call the initial node. If you're on the initial node, then it will only go down one direction. But then if you're no longer on the initial node, it will grab nodes from both directions. But it will never go back up from the initial node. Now these functions, I think, are in the editor. If we're going to use upstream and downstream get downstream. So I think, Steve, you're saying the same thing as I'm struggling to say. So get downstream meaning, I don't know if you heard that, something just fell over in the kitchen. So get downstream meaning where a message goes seems like a reasonable result for a function named as such. Yep. The node read information is more of a get nodes connected to the right. Yeah. So I think in the editor, because these are all internal functions in the editor, I think we can refactor what we've called things in the editor more easily. The only slight fire in the ointment is we do expose it as an action. Select downstream nodes and select upstream nodes. But yeah, we can tidy that up. We can add we can correct those implementations, but also I'm not going to worry about it. But the point is, I think the flow parser is right to say everything downstream is talking about stream. It's like the flow of water. So I think the metaphor is right, saying if it's downstream, if I drop a message into the stream at this point, here's all the places it could flow to. That seems like a sensible mental model for the naming of the functions. So on that basis, let's fix our test, because let's fix the test. So we're saying that downstream of node 2 is nodes 3, 4, 5, 8 and 9. And in fact, having this node 10 here is a useful test case of this behavior. So what did I say? 3, 4, 5, 8 and 9. 3, 4, 5, 8 and 9. Yep, and that passes. Okay, let's do the upstream equivalent. Branches on a single input. Again, I'm not sure these test titles are as helpful as they could be, but in this instance we are going to go from flow 5 node 4, and we're saying flow 5 node 4 upstream will hit nodes 1, 2, 3, 6 and 7. 1, 2, 3, 6 and 6 and 7. Evening electric trick. Yes, electric trick. I had to read that twice. Welcome to the live stream. If it's the first time you're joining or first time saying hi in the chat. Good. And so our tests are passing. The basic. I think that is basically working. What I now want to quickly add is the virtual path handling. So link nodes. So at the moment we're just calling this without. So both get upstream and get downstream, just like the ones we did last week. These functions also take an optional Boolean parameter as to whether we should follow virtual links or not. So I don't want to, because I'll be renaming these nodes. I don't want to make these flows overly complicated. In fact, I'm going to make my life easier by shrinking this one down to oh no, we're up to flow 6. 6 node 2 and 6 node 3. Then we're going to add a link. What did I call these links? Yeah, link 1 and link 2. So this is going to be flow 6 link 1. No, it's not. That's going to be link 2 because I've put the wrong one in. Well, I haven't put the wrong one in. I've not put the one I expected. And that's complaining because it's not been named. So this one is flow 6 link 1. Okay, and then we'll stick flow 6 node 4 on this one. Good, good. I'll just get that on the grid. All right. Yep. Going to live with that. So let's export. Just close some tabs. Right. Save the updated test JSON. So we're now going to do downstream and we're going to say does not follow virtual links by default, and we're going to go from well, 6 node 1, why not, 6 node 1, and we expect that to return 6 node 2, 6 node 3 and 6 link 1. So we expect 2, 3 and link 1 for flow 6. And then, because I'm feeling brave, let's just, oops, don't cut it. Let's copy, paste it, and say follows virtual links when asked. So we ask by passing in true. Now we, as well as 2, 3 and link 1, we also expect to get link 2 and node 4. Basically everything. Cool, cool. Let's see, does this run? It does, it passes. Very good. So now we just do the reverse test for Getupstream. And this time we're going to start, find the right window, we're going to start at, let's start down here, 6 node 4 is where we'll start. And we expect that to only hit link 2. Whereas if we set the virtual link, if we pass in true, oh, we also need to change these for Getupstream because that's what we're testing in this block. And then following virtual from 6 node 4 is, hold on, let's check. Oh yes, node 4. Hopefully that's what your Uncle Jay is pointing out for me. Yeah, flow 6 node 4. Oh no. Yep. Oh, too many numbers. Right, let me just. Have I. Yeah. Flow 6 node 4 is what I want. Flow 6 node 4. This node here. If we're not following virtual, we'll only get 6 link 2. If we are following virtual, we'll get link 2, link 1, node 2, and node 1. So node 1 and node 2 and both the link nodes. And that passes. Good, good. Just for sanity check, if I change one of the nodes we expect, there we are. Yeah. Always feel better when you see a test fail and then know it's capable of failing rather than write all this tests and then it's all passing and it turns out you're not actually testing anything. Okay, so that's done downstream, that's done upstream, virtual links, not virtual links. Then is this, no. Do we have a combined? Get all nodes, including this one, reachable from its inputs and outputs. Yeah, so this is one we now need to test. And what's interesting, if you look at its implementation, it doesn't use upstream and downstream. It does get sibling nodes. So it literally just walks every node and says, give me everything either side of you, and keeps walking the graph until it gets everything. So, yeah, so this is should be pretty quick using the flows we've already got. We don't need to, no need to create lots of new test cases, I don't think. So get connected nodes. What we're actually going to do for get connected nodes is we're going to start on flow 6 link 2 and get connected. So without the virtual flag, that should just return 6 node 4. Whereas if we call it with get connected nodes true, it should return absolutely everything. So what have we got? We've got 4 nodes and 2 links, but it doesn't return itself. So basically it should be a list of everything but itself. I think that makes sense. Expected 6 to equal 5. So let's just double check what we say. Get all nodes including this one. Key point then. So what I'd said at the end was I should have scrolled up. Both tests have failed because they both, unlike the get upstream and get downstream, get connected nodes is the complete set. That should be linked to. So it actually includes the node you're calling it on. So yeah, and that now passes. Awesome. Well, why is it itself connected? There is a degree of, well, that's what the docs says it does. So it says it includes itself in that array. Should it be there or not is an interesting philosophical question. Is that the right behavior? Before I attempt to philosophize on that, I'm going to quickly go have a look. I'm delving into the Lint Tool. So the Lint Tool is our one consumer of this API. And I just want to check. Right, it doesn't use get connected nodes, which is good. In fact, where is it? It's the loops. It's the loops one that checks whether you have any loops. See, it only uses get next and get previous nodes. So I was just checking that, because if we decide actually get connected nodes shouldn't include itself, then I'd have to coordinate a change with the Lint Tool. But given the Lint Tool doesn't do that, then it's fairly safe for us to decide actually the right behavior is for it to not include itself. Because philosophically, none of the others return the node itself. It's all about the other things, all the other nodes connected. And it's actually easier for an implementation to call that and then include the node ID of what it's just called it on if it wants that complete set. Yeah, that's probably a cleaner way of doing it. So let's change it. We're going to say get all nodes not including this one reachable from its inputs and outputs. There we are. We've changed the definition of the function. Now we just need to fix the implementation. So what we want is we only want to push the node onto the result if, well, we still need to visit the initial node because we've got to get its siblings, but we only push it onto result if node ID is not equal to this ID. Seems reasonable. So let's, well, if we set this visited before, if we were to do that, then we would never enter Steve. So if I didn't do that guard, and if I said up here, visited this.id equals true to avoid, we would then, for this first node, we'd never enter the if block that does the work to get the siblings. And we want to do that work. So yeah, there's a few different ways you could structure it. We could, rather than initialize the stack to being this, we could initialize the stack as being the get sibling nodes. In fact, why don't we, the other way of fixing it is saying initialize the stack as being all the sibling nodes and set initialize visited. Oh no, we can't do it like that. We can say visited this.id equals true. Yeah, same result. And it means we're not doing that if state. We haven't added an extra if statement inside that for loop. So, you know, it might be marginally more efficient. Ooh. And it helps if I spell visited right. And the test's still failing, but is that, yeah, that's because I forgot. Right. I hadn't got to the point of removing the own node ID. Uncle Jay, good question. Very good question. And we should have a test case for this. Loops. So let's create a flow with a loop in it. Yeah. Can we? Yeah, it's ugly as anything, but it's a loop. In fact, yeah, I'm just going to simplify it a bit. There's no value in having all those nodes. Let's do it like this. Plus, it's fewer nodes for me to have to relabel. 7. So yeah, you're right. The code has to take care of loops, and loops are possible. And this is a little artificial for it to look like this. In fact, why don't I make it a bit more visually pleasant? Ooh dear, that didn't make it more visually pleasant. Blimey, that's an interesting edge case of wiring that the routing algorithm doesn't like. Look at that, that's awful. Why is it not looping down the bottom? Okay, I'm going to lose sleep over that crappy looking wiring. I mean, I'll get over it, but I spend so much time with our wiring out, trying to get these curves just right. And the fact that that's just hitting the node like that rather than curving up above the node is just ugly. Right, but look, I'm growing as an individual. I'm moving on. I've left the flow like that. I've exported it, and yeah, Steve, imagine node 2.0 and we'll have a entirely different routing algorithm, just to sate my OCD. So we want to handle loops. We want to check loops in a few different cases. So get downstream nodes. Let's just copy one of these. Yeah, so those yellow exclamation marks are the linter, which at the moment, the tooltip doesn't tell you what the linting error is. If I go have a look, there it is. Loop detected. See? The rule works. Yeah. Now, the algorithm it doesn't list all the nodes, warning about all the nodes that are on the loop. Basically, this was the node it was examining when it found the loop. So that's the one that gets the error. And I can actually tell it to ignore for that node, and then it will report it on one of the other nodes, I think. But anyway. Yeah. Where were we? It distracted me after I'd pasted something. I forgot what I pasted. Where are we? We are in get downstream nodes. Does not get stuck in a loop. For want of a better title. So we're doing downstream nodes. We're going to go from 7 node 2. And by our definition, anywhere a message can reach. So we expect it to return 7 node 3 and 7 node 4. And 7 node 2 should not be included. Even though it does loop back, it will never return itself. So we expect it to be nodes 3 and 4. Didn't save the flow JSON, I don't think. Yep, so that's passing. Does not get stuck in a loop. So that's working. And then let's just do the same test case for upstream. So when we want to test going upstream, we are going to test from 7.3. And we expect to get 2 nodes 1 and 2. Ooh, failed. So get upstream nodes does not get stuck in a loop. Starting at node 3. Oh, yep, I knew that was going to happen. Copy and paste error. I was calling get downstream. Cool. So if I call the right function, then the test passes, which is awesome. And let's copy and paste one more time for the get connected nodes. Basically, it's all the functions that do more than one hop have to worry about loops. So get connected nodes, doesn't really matter where we start it. I'm going to start at node 2. In fact, no, yes, I'm going to start at node 2, and I expect to get nodes 1, 3, and 4. 1, 3, and 4. And that passes. Cool. Well, thanks for that, Uncle Jay. Yeah, the loop is really quite important to test loop handling. Should we be testing loop handling across virtual links as well? Well, maybe we should. I'll tell you what we'll do. Let's just run npm run test, npm run coverage HTML. And if I go back to the code coverage report, refresh, a lot of that red has disappeared. Let's go back to the summary. So NR node is now at 96%. Awesome. So everything's looking green and healthy. The next one down is Subflow instance. And yeah, it has very little code in it. So yeah, the test would be yeah, I'm happy with that as it is. It's basically 2 lines of code that aren't explored, and they're error cases that will never happen, can never happen with a well-formed flow. So yeah, that's fine. And our wire, yeah, the one line we don't test is its toString function, which is only really used for debugging. So again, I can live with that. And yeah, it's for debugging. So the toString format, I'm not going to start validating that it looks right when we toString it, because it's for debug. So that reserve the right to change its output format. Yeah, just handling some sensible defaults. Oh, export content. That's interesting. The fact we've got. I'm just trying to work out why export contents is not being called on this group. Don't worry, I'm not going to worry. Yeah, I mean, that's looking green. It's up in 97% total statements. I think we can call that a success, as it's now 9 o'clock. Yeah, we'll run with that. I'm just going to add more tests to NR node. Cool. So that's a bit more work on the flow parser. I mentioned at the start, one of the other things I was going to think about poking with, but to be honest, I think it's a bit late now. That one of the facilities I want to add to the flow parser is being able to diff two flows. So given 2 versions of a flow, give back a piece of structured metadata about what is different between those 2 flows. We've already got a lot of that code in the core of Node-RED. The merge tool in Node-RED does that, but it is wrapped up in the core of Node-RED in the editor, which makes it hard to reuse elsewhere. And I think I said last week, somewhere I'd like to try and get to is this flow parser is something we actually start using in the core, maybe even in the editor. It needs some Webpack to transpile it to be browser friendly, like we do in the Lint tool. But yeah, so where is it? In, I think, utils. If we collapse all them down, is there? What's get browser info doing? Who's added browser sniffing? Oh, that was you, Steve, wasn't it? Doing the Monaco stuff. Anyway, sorry. Sometimes I get distracted when I see code I don't recognise. Yeah. Yeah, no, I guess that was... I think as soon as I saw it, I remembered, yes, that was Monaco stuff. No worries. Okay, so it's not... What I'm looking for, though, is not in that file at all. But there is diff.js. Is it in here? This does all the work. Oh, here we are. Generate diff. Yeah, this is what does all the hard work. Is that really all that does the hard work? There must be more to it than that. Oh no, parse nodes, parse, yeah. So here we have parse nodes, which effectively does what the flow parser is doing. No, it's not. What's going on? It just feels like there's a whole... I'm sure this code should be longer than this. Maybe not. Maybe it's simple as that. But anyway, this code, given two flows, gives back an object that gives you the current config, the new config, so like the from and to, and then objects of what's been added, what's been deleted, what's been changed, and what's been moved. Which, yeah, things we need to know, and it's useful. One of the problems we've got with doing version control of raw JSON is it's meaningless to diff lines of JSON. It's much nicer to have a more contextual diff of the data, of the information in the JSON. So if you want to build a more like a standalone diff tool for Node-RED flows, then the flow parser is going to be central to how we do that. Yeah, so that might be something for Monday. Guess it depends where we are with 2.0. Yeah, a diff tool is not a high priority at the moment, so it's an interesting exercise. And often this Monday evening is me dipping a toe in interesting bits that I can wrap up in an hour rather than just slogging through some development work on other bits. But yeah, who knows? Something to come back to. Cool. Well, it's 9:05. I think I'm going to pretty much wrap up there. Oh, that's committed. Let's push. Cool. So that's now up on GitHub. So if anyone wants to play with the flow parser, do have a play. It's one of those libraries that needs lots more documentation for it to be as useful as it should be, but we can slowly just peck away and try and... The goal is to keep it a nice clean API so people can build utilities that work with Flow.json with it. Yeah, that's the goal. Anyway, I hope you all have a lovely week. Yeah, keep an eye out for 2.0 later this... Well, I'm going to get it ready to release later this week. I suspect we won't release it until early next week. Yeah. Oh, sorry, Uncle Jay, what's this? What is when you start Upstream on Node 2 is Node 3... Oh, see, you're still... I was ready to go home for that night. Right. When you start Upstream on Node 2, is Node 3 then also included? Yes. So in this instance, where we define Upstream as anything... You know, if a message was to swim up the river of the flow, then it would be able to reach Node 3. So yes, Node 3 is in a curious state of being both downstream and upstream. But that's what you get when you get loops. But yeah. Yep, an infinite loop. Oh yes, you're right. There's something pleasing about it being the infinity symbol, but slightly skewed. Anyway, I'm going to stop looking at that until I get too stressed about the fact these curves just aren't quite as symmetrical and as nice as I'd like them. and I'm going to walk away from my laptop. So have a great week, guys. As ever, come say hi in Slack if you want to chat about anything you've seen here. Otherwise, I will be back next week. Have a great week, and yeah, there we are. Good night. Bye all.